welcome back to Code Stack. If you are new here, do not forget to like, subscribe and turn on the notification bell. Before we start, let me ask you a simple question. When you run a program, what does it use more? Time or money? Most students talk only about time. But today we are focusing on something just as important, money. In this video, I will teach you space complexity in a very clear, practical way with examples you can actually understand. What is space complexity? Let's begin with the idea. Whenever a program runs, it needs memory. Memory to store the input, variables, arrays, function calls. Space complexity measures how much memory and algorithms use as the input size grows. So the key thing to remember is this: space complexity is not about exact memory size. It's about how memory grows when input increases. Simple analogy: think of a school bag. More books, bigger bag needed. More inputs, more memory needed. Now let's talk about difference between time and space complexity. Now let's clearly separate two ideas. Time complexity asks how long does the program take to run. Space complexity asks how much memory does the program need. Sometimes one algorithm is fast but needs a lot of memory. Another is slow but saves memory. In real life, both matter. That's why we study space complexity. Now let's talk about why space complexity matters. Why should you care about space complexity? Because memory is limited. If a program is used too much memory, it may cache, it may freeze, it may not run on mobile phones or smaller devices. That's why space complexity is very important in labs, embedded system, large software system. Smart programmer always think, can I solve this using less memory? Next one is type of memory used in program. Now let's see where memory is used. There are four types: stack memory, heap memory, code space, static or global memory. In stack memory stores local variables, function calls. Every time a function is called, new stack frame is created. That's why recursion use more stack memories. Next one is heap memory. Heap memory is used for dynamic data, arrays and objects. Whenever you create an array or object, memory comes from heap. Next one is code space. Code space stores the program instructions. Memory is fixed. One is global or static memory. This stores global and static variables. It is allocated once and stays until the program ends. Now let's talk about very important topic: difference between input space and auxiliary space. When we calculated space complexity, we divide memory into two parts. First one is input space and second one is auxiliary space. In input space is the memory used to store input. Example, int array n. If n increases, memory also increases. Input space is 0n. One is auxiliary space. Auxiliary space is extra memory used by the algorithm excluding input. In example, int sum equals 0. Only one variable constant memory. Auxiliary space is 0, 1. Total space complexity is equal input space plus auxiliary space. Next one is big O notation for space complexity. We used big O notation to describe space complexity. 0, 1 is constant memory. 0n is memory grows with input. 0n squared is memory grows very fast. 0 log n is we always ignore constant. Next one is common space complexity. In constant space, memory does not change. Int x equal 10. In linear space, memory grows as input grows. Int array n. In quadratic space, usually cased by 2D arrays. Matrix n into n. Now let's talk about space complexity of data structures. First, remember this important idea. Most data structures use linear space. That means when the amount of data increases, the memory usage also increases in a linear way. Now let's look at some common data structures one by one. First one is array. An array stores n elements, so it needs memory for all n items. If the number of elements increase, memory usage also increase. Therefore, space complexity is 1n. Next one is linked list. A linked list is also store n nodes. Each node needs memory for data and a link needs mean more memory. So, space complexity is 0n. Third one is stack. A stack stores elements one on top of another. If there are n elements, if needs memory for all of them. So, space complexity is 0n. Fourth one is queue. A queue also store n element. Memory usage depends on the number of items in the queue. So, space complexity is on. Fifth one is trees. A tree contains n nodes. Each node uses memory. More needs mean more space. Therefore, space complexity is 0n. Last one is graph. Graph stores vertices and edges. Memory is needed for both vertices and edges. So, space complexity is 0 v plus e. Understanding space complexity helps us choose the correct data structure. If memory is limited, we must select a data structure that uses space efficiently. Next topic is how to analyze space complexity. Now I will show you how to analyze space complexity in exams. This method is simple, safe and works in interviews too. Whenever you see a problem, follow those steps in order. First step is set input storage. First check how much memory is needed to store the input. If the input size is n, input space is usually on. Second step is look at extra variables. Extra variables used in the program. Simple variables like int, sum, count, those take constant space 0n. Next one is step 3. Look at array or object. In the program use arrays, list, objects and data structures. Then memory depends on their size. Size n, on, n squared or n squared. Fourth step is recursion depth. If the function is recursive, each call use stack memory. Count how many recursive calls happen. Depth n, on, depth or log n. Ignore constant. Do not worry about plus 5, 2n, n plus 10. We always ignore const in big O. Sixth step is write a big O notation. Finally, write the highest ordered term as the answer. That is your space complexity. Final rule to remember: input, extra memory, recursion, ignore constant, write big O notation. This method works in exams and interviews. Now let's talk about space complexity in recursion. This is very important exam and interview topic. Just remember this rule. Recursion is used extra memory of the calls stack. Every time a recursive function is called, a new stack frame is created in memory. Let's look at an example. Here the function keeps calling itself until n become 1. If we call factorial 5, there will be 5 recursive calls. Each call is stored in the call stack. Call use stack memory. So memory usage increased with the value of n. Space complexity analysis. Number of recursive calls equal n. Stack space used per call is equal constant. Total stack memory is equal n calls. Therefore, the space complexity is 0n. Rule to remember: space complexity in recursion equals depth of recursion. If recursion depth is n, space complexity is 0. Now let's understand space complexity using clear two examples. I will analyze each example step by step. First example is iterative function. Now let's look at example. Now look at input space. The input array store n elements. Input space is 0n. Next look at extra variables. Variable total. Use constant memory. Extra space is equal 0, 1. Next, check recursion. The function is not recursive, no stack growth. Final answer is input space 0n, extra space 0, 1. Total space complexity is 0n. Let's talk about second example, recursive function. Look at the example. Now look at input. Input is a single variable n, then input space is 0, 1. Next, look at recursion. Function calls itself n times. Each call use stack memory. Call stack grows n levels. Final answer is number of function calls equal n. Stack space equal n. Therefore, space complexity is equal 0n. In iterative function usually use less space. Recursive function use extra space due to the call stack. So let's summarize today's lesson. Space complexity measure how much memory an algorithm use. It includes input space and auxiliary space. Recursion increase space usage because of the call stack. Big O notation helps us compare algorithms easily. Once you understand this logic, space complexity is no longer confusing. If this video helped you understand space complexity, please like, subscribe and comment below. Thank you for watching. I will see you in the next video.